Okay, so I am going to teach the first part of 7.5 on logistic growth. I talked a little bit about it last class, but before we get into logistic growth, the first part of 7.5 is actually on partial fraction decomposition, which is something that you learned back in pre-calculus. There really wasn't a lot of application for it, but we're going to be using that to simplify a quotient so that we can take the integral of it. Okay, so let's start. So this is, I'm just talking, oh, I realize this should be 7.4, not a big deal. We talked about food, habitat, living space. These are just a few constraints that, you know, this is one of the reasons we have this logistic growth. So partial fraction decomposition, where we have a quotient, right? P and Q are polynomials with the degree of P less than the degree of Q. All right, what we're going to do is we are going to rewrite it as the product of distinct linear factors. And then f of x can be written as the sum of rational functions with distinct linear denominators, which is going to allow us to integrate it much more easily. So let's take a look. We're not going to integrate yet. We're just going to practice this partial fraction decomposition. Here we have our first example. Okay, 2x plus 16 over x squared plus x minus 6. Again, the degree of the numerator is less than the degree of the denominator, so this is an example where we would use it. We can try different things when we get to integration. This is just one other method. So here's what we want to do. We're going to leave the numerator as 2x plus 16, and we're going to factor the denominator. This is going to become x plus 3 times x minus 2. So we want to rewrite this so that it is a sum of rational functions, meaning we are going to split up those two factors, which were x plus 3, and then we're going to have plus b over x minus 2. Okay, so what we need to do is we need to figure out what a and b are, and then we can integrate each part. So we are going to have, again, this whole thing, these are equivalent to each other. So almost think of like, what would we do if we were starting with this, right? We'd want to find a common denominator, which would be, we would want to multiply a times x minus 2, right? And then we would multiply, right, x minus 2 over x minus 2, and then we will multiply b over x minus 2 times x plus 3 over x plus 3. And this whole thing is going to have to be equal to the numerator of what we started with, which is 2x plus 16. Now, this here, this is going to be true for all reals, for all values of x. So what I'm going to do is I am going to let x equal positive 2. So again, this is true for all x. So I can make x equal to anything. Now, why would I pick 2? Well, it wipes out that first term, right? That would be a times 0. And then let's see what happens here. So this will be 2 plus 3, so that'll be 5. And then on the right side, 2 times 2 plus 16. So I'm going to have 5b equals 20, which implies b is equal to 4. Okay, now take a look at b. b times x plus 3. So I want to wipe that term out. So this time I'm going to let x equal negative 3. So I'm going to have a, and then negative 3 minus 2, so that's going to be negative 5. 2 times negative 3 plus 16. So we're going to have negative 5a equals 10, which implies a is equal to negative 2. So now we can write this as a sum of rational functions with linear denominators. So we go back to what we started with, right? So we have these two, and now we're going to go back and rewrite this. So this is going to be negative 2 over x plus 3 plus 4 over x minus 2. And that's what this is equal to. Let's take a look at the next one. Okay, so first step again, we're going to factor. This is going to be x plus 3 times x minus 3. So we want to rewrite this as a over x plus 3 plus b over x minus 3. So again, I'm going to take a times x minus 3 plus b times x plus 3, kind of not cross multiplying because there's a plus, but if it's easier for you to remember that way. And then this whole thing has to equal 3. Now again, I want each of these terms to drop out. So I'm going to let x equal 3 first, or negative 3, it doesn't matter. That will make this term all go away. And so I'm left with 3 plus 3, so that'll be 6b equals 3. So b is a half. Then we'll let x equal negative 3. So negative 3 minus 3, so that'll be negative 6a. The term with b in it will all go away, and we get 3. And so a is going to be negative 1/2. So therefore, this is going to be equal to negative 1/2 over x plus 3 plus 1/2 over x minus 3. Now, it's kind of messy looking. I'm actually okay if you leave it like that. If you really want, you could, get rid of the complex fractions, and you could do negative 1 over 2x plus 6, and then plus 1 over 2x minus 6. Again, I'm fine if you leave it this one, because when we're really going to be evaluating these, we're going to be doing integrals, so it's actually easier if you just leave the 1/2 the way it was. Okay, evaluate each integral. So we are going to be doing this by partial fraction decomposition. So before we do that, let's write this. So 5x plus 14 over x times x plus 7. So we'll have a over x plus b over x plus 7. So I have a times x plus 7 plus bx equals 5x plus 14. Okay, so when x equals negative 7, plug that in. We should get negative 7b equals, and that's going to give us negative 21 here. So b is equal to 3. When we let x equal 0, that's going to give us 7a equals 14, which results in a equals 2. So I can rewrite this integral, right? So kind of thinking, take these values, right, and plug them in here. So we're going to rewrite that integral as 2 over x plus 3 over x plus 7. And so that's going to give us 2 times natural log absolute value of x plus 3, natural log of x plus 7 plus c. Okay. Next one. So let me work with the partial fraction decomposition. So 1 over 3 minus x over 3x squared minus 5x plus 2. It's going to be, this is going to be, let me just factor this here. Sorry. So let's see, this is going to be 3x minus 2, and then x minus 1. So it's going to be a over 3x minus 2 plus b over x minus 1. So a times x minus 1 plus b times 3x minus 2 equals 1 minus 3x. when x equals 1. Right, so that's going to be b equals -2. And then when we let x equal 2/3, we're going to get a equals 3. So I'm going to rewrite the integral as 3 over 3x minus 2 plus, actually I'll just write that as a minus 2 over x minus 1, and then dx. Over here, oops, so equals, now technically 3 over 3x minus 2 would need a u substitution. I'm going to use my shortcut here, so it's going to be 3 natural log absolute value of 3x minus 2 divided by 3 minus 2 natural log absolute value of x minus 1 plus c. So we get natural log 3x minus 2 minus 2 natural log of x minus 1 plus c. Now you can do some more logarithmic properties here. You know, you can move the 2 to the exponent if you wanted to. You can make this into a division. For right now, I'm going to suggest just leaving it like this. You can manipulate it later if you need to. Okay, quick reminder. You do not always need partial fraction decomposition to integrate a rational function. Don't forget that there are other methods. Oh, ignore the fact that I got an extra parentheses there. Okay, so this one, I would recommend u substitution, right? I would make u equal to x squared minus 1. So du is 2x dx, which I happen to have here. So therefore, this can be rewritten 1 over u du. So we get natural log absolute value of u plus c. So natural log absolute value x squared minus 1 plus c. Next one. So 2x cubed over x squared minus 1. I would recommend, since the numerator is larger than the denominator, to try doing long division. So we're going to get 2x, so that's going to be 2x cubed minus 2x. So then plus 2x over x squared minus 1. So this whole thing, probably should have given you a little bit more room, can be rewritten as the integral of 2x. Let me put this all in parentheses just so I remember. So 2x and then plus 2x over x squared minus 1 dx. So let's see here. This is going to be 2x squared over 2, so that's going to become x squared. Let me just take a look at this part here, because this in and of itself is a u substitution. Now, interestingly, if you compare this example, we just did that part above. So we can see that just this part resulted in natural log of the absolute value of x squared minus 1 plus c. So I'm just going to put it all together just to save some time. So I get x squared plus natural log absolute value of x squared minus 1 plus c. Okay, so that's what you're going to be working on for homework. We're going to pick up logistic growth next class on Thursday. So just do the problems that I have listed on the lesson plan for today, which is a practice. Don't worry about what I wrote. Just look at the page 376 here, 5, 9, 11, 15, 19, and 21. And email me if you have any questions.